I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. We'll unlock the way we rock it, so don't stop.
Hello everybody, isn't this exciting? It's another day of math. Welcome back to my virtual class and through virtual learning through YouTube or however you are watching these videos. Welcome back to learning some math, okay? Today we're going to be learning about angles as fractions of a circle, okay? So today's TEKS 4.7a, that is illustrating the measure of an angle as the part of a circle whose center is at the vertex of the angle, that is the cutout by the rays of an angle. Angle measures are limited to whole numbers, okay? And so basically what we're going to be doing is relating angles to fractions through a circle, okay? So like I said last time in the last video, in one of the last videos, that remember how last semester we were able to relate decimals and fractions together through number lines, through money, through everything? Well, now we're going to relate angles and fractions through circle. It's a circle of life. I don't know how to make a circle. Right there. There you go. Okay. And part of that is also going to be doing 4.7b, which illustrate degrees as the unit used to measure an angle, where 1 out of 360 of any circle is 1 degree, and an angle that's cut out of is end, which we need to figure out what end means. Remember, out of 360 out of any circle whose center is at the angle's vertex, okay, has a measure of an n degree, which is what we need to figure out, okay? And angle measure are limited to whole numbers, okay? So that means we're only going to be using whole numbers. Let's go ahead and look at our learning goal. Students will know how to measure angles. Students will understand how to identify the vertex of an angle, and students will be able to share in a group discussion how to illustrate the measures of an angle as the part of a circle whose center is at the vertex of an angle that is cut out by the rays of an angle. Sorry, I don't know where that went. Okay, let's go ahead and look at this real world connection. So when a snowboarder jumps and spins in the air, it is often described as a 180 or 360, okay? Or if you know that song where it goes, if you don't wanna see me do the full 180, crazy, thinking about the way I was. Anyways, by Dua Lipa, okay? So a lot of people do 180 and they turn around. And yes, that's a 180, okay? But if you see people doing, and I did 180, and they circle back, okay? And they circle back, no, that's a 360, okay? 360 when you go all the way around and you're back in the center. 180 is when you only turn halfway and you keep going, okay? So let's go ahead and look at this video. So we're gonna check out this video that's showing you how to do a 360 in a snowboard. Don't try this without proper training, okay? So basically, don't do this at all. Especially my kids. Don't do it at all. Oops. Oh. Let me choose. Oh my goodness gracious. What? What? I can't do that. Anyways, so let's go ahead and look at some vocabulary, and then we're gonna watch another video that's gonna show us how to actually do all these things that we need to learn in math. Okay, so remember, an angle is when two rays have a common endpoint. Okay, that is what an angle is. A unit angle, okay, is an angle that cuts off 1 out of 360 of a circle and measures 1 degree. Okay. What do you think that sounds like? A unit angle. Exactly, a unit fraction. So remember, a unit fraction has a 1 in my numerator, right? A unit angle is out of a circle, right? A circle's degrees is 360. So that's going to be my number on the bottom, which is called what? Who remembers that? Good, a denominator. So 360 is going to be my denominator. And because it's a unit angle, a 1 has to be on top. Excellent. A protractor and degree. So I kind of already explained this, but here it goes. A protractor is a tool mathematics use to measure angles, okay? The tick marks represent degrees, the unit of measure for an angle, okay? So remember how I kind of said protractor is kind of like the ruler except for angles, right? And then the degrees is the unit of measurement, like inches and centimeters for a ruler, okay? Angle measure. An angle measure in degrees, okay, is measured in degrees. Count from 0 degrees to the angle measured shown on the protractor, okay? All right, let's go ahead and look at our mini lesson. Okay, what you should know is a circle has 360 degrees total, okay? So the whole thing is 360, okay? A straight angle has 180 degrees. Remember, that's a line. So if that's a line, then that means that's half of the circle, which is 180, okay? A right angle only has 90 degrees, so that means that's a quarter of the circle, okay? So the whole circle itself is 360. Half of that is 180, which is a straight angle, and then half of that is a right angle, which is 90 degrees, okay? Don't forget the types of angles, okay? So remember, an obtuse angle, it measures in that's greater than 90 degrees but less than 180, because 180 will turn into a straight angle. We have a right angle that measures exactly 90 degrees. Then we have an acute angle that measures less than 90 degrees, okay? So identify the angle. The hands on the clock make an angle. Suppose one hand points to 6 and the other hand points to 9. How could you describe the angle, okay, made by the two hands? So one hand is pointing 6, which is down, and the other one is pointing 9, which is like this. Okay, so basically like this. Oh, there we go, sorry. So basically like this. So how would you describe that? The clock hands form what looks like a square corner, which is this right angle. A right angle measures exactly 90 degrees. Okay, and see how the clock is like a circle, and the whole thing has 360 degrees. Equal parts of a whole. Let me just be up here. A circle is divided into 8 equal parts. What is the angles measured of one of those parts? Okay, so let's go ahead and look at that. So a circle has how many degrees? Good, 360. Okay, and it's divided into 8 equal parts. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Divided into 8 equal parts. We need to know what one of them is. What do you think we can do? If I know my total is 360, and I'm gonna divide this whole thing into 8 equal parts, and they're all equal, What type of operation does it sound like? Good, division. Okay, since the circle is 360 degrees total and we have 8 equal parts, we can divide. So 360 divided by 8 will equal 45. 45 what though? 45 degrees, okay? So that means this angle is 45 degrees. And what type of angle is that? Good. An acute angle. Okay, equal parts of a whole, no, sorry, continue. Okay, so what is the measurement of 3 parts? Okay, so I want all these 3 together of this angle, okay? What do you think I would do? If I want all these 3 together, okay, and this huge angle, what do you think I need to do? What operations? Good, I would need to add. What am I adding? Good, 45, because each one is 45. So that means I could add 45 plus 45 plus 45. Or what do you think I could do to do much faster? Yes, that is correct. I could multiply 45 times 3. Perfect. Which would equal what? Good, 135. But 135 what? Degrees. Excellent. Okay, and what type of angle is 135 degree? Good, obtuse angle. All right. Alrighty, and we're just gonna watch this quick video, and it's gonna help us explain better on what this how to do the circles and angles. Okay.
And they all share the center point as a vertex. And we can relate the 1/12 size part of a circle to a clock face. 3/12 is equal to 1/4. And the angle formed by a 1/4 piece is 3 times as large as a 1/12 piece. That's why it takes 3 of these to equal one of these. And 3/12 is equal to 1/4. If you remember from simplifying fractions, this video is linked into the description. We have 3/12. We divide both the numerator and denominator by the same common factor that they have. They both have a common factor of 3. So we do 3 divided by 3 is 1. 12 divided by 3 is 4. 3/12 is equal to 1/4. We can relate fractions and angles to the hands of a clock. We can think of the hands of a clock as the rays of an angle. And a clock's hands go clockwise. And if we go opposite the directions of a clock's hands, we're going counterclockwise. Each 5-minute mark on an analog clock represents 1/12 turn going clockwise. From the 12 to the 1, that's 5 minutes. To the 2, that's 10. To the 3, that's 15. And each number is 1/12 of the hour. 1/12 is one of 12 equal parts. This would be 1/12. It's 5 minutes for the minute hand. 15 minutes is 3 of 12 equal parts. It's 3/12. We can see the minute hands pointing to the 3 out of the 12 numbers. It's 3/12. And 3/12 is equal to 1/4 turn clockwise. It's 1/4 of an hour. 30 minutes, we can see the minute hands pointing to the 6. That's 6 out of 12 equal parts. It's 6/12. It's equal to 1/2 turn clockwise. That's 1/2 of an hour. 45 minutes, we see it's pointing to the 9. It's 9 of 12 equal parts. It's 9/12. That's equal to 3/4 turn clockwise, or 3/4 of an hour. And 60 minutes, that's 12 of 12 equal parts, or if we're looking at it as fourths, it's 4/4. That's 1 whole turn clockwise. It's 1 full hour. And 15 minutes is 1/4. we can do 15 minutes plus 15 plus 15 plus 15, which is equal to 4 times 15 minutes. That's 60 minutes for an entire hour. And any 15 minutes is 1/4 of an hour. We have 5, 10, 15 minutes. That is 1/4 of an hour. If it's hard to tell if it's 1/4 of an hour or what fraction it is, we can turn our paper or our book. We can turn it so this 4 is on the top where the 12 was. We can see that this is 1/4. Any 30 minutes is a half an hour. It doesn't matter where it starts. We could turn this clock so the 8 is on the top. We can easily see that that's half of the hour. And any 45 minutes is 3/4 of an hour. Again, if we're having trouble seeing it, we can turn this so that the 1 is on top. We can see it's 3/4 of an hour. We can tell what fraction of an hour has passed on an analog clock starting at any minute. We can tell what fraction.
And that is it. I'm gonna give you your exit ticket right now. I hope you learned a lot from that video because it's gonna help us a lot with learning about angles and everything. Okay, exit ticket time. Which angle shows 1/2 turn counterclockwise? Which angle shows 1/2 counterclockwise? A, B, C, or D? I will see you later for our next math topic. Bye.